Okay, we'll look at some of the homework problems in section 5-3, and we'll start with problem number 1. 8 is divisible by 16, and we want to know, is this statement true or false? All right, for 8 to be divisible by 16, that means if I take 8 and divide that by 16, I have to get a whole number with a remainder of 0. In this case, I would not get a whole number with a 0 remainder. So here, 8 is divisible by 16 would be false. Because if I do 8 divided by 16, I'm going to get 1/2. And 1/2 is not a whole number. All right, number 2 is to use the divisibility test to answer each of the following. Let's say in this problem here, can 709 passengers be assigned to 9 flights so that each flight has the same number of passengers? Well, there is a divisibility rule for 9. That means that the sum of the digits in 709 must be divisible by 9. So if you add 7 plus 0 plus 9, you're going to get 16. And I know 16 is not divisible by 9. So 709 would not be divisible by 9. So in this case, to answer that question, I cannot have 709 passengers cannot be assigned 9 flights in a way that each flight will have the same number of passengers. So the answer there would be no. All right, this next question is this. Can a parking lot designed to accommodate 3,454 cars be divided into 11 equal rows? Well, there is a divisibility rule for 11. That means that the sum of the first and the third number minus the sum of the second and the fourth must be divisible by 11. So if I add 3 plus 5 together, I'm going to get 8. And if I add the 4 plus this 4 here, I'm also going to get 8. And if I subtract 8 minus 8, I'm going to get 0. And of course, 0 is divisible by 11. So in this case here, the answer would be yes. Or you could divide 11 into 3,454, and you will find out that you would get a 0 remainder. All right, this next problem, can a theater charging $12 per person for admission to a play take in exactly $5,680 for a night's performance? Well, there's no divisibility rule for 12, but I know this. 12 can be broken up into 3 times 4. And I know there are divisibility rules for 3 and for 4. For 3, the sum of the digits in 5,680 must be divisible by 3. And for 4, the last 2 digits in 5,680 must be divisible by 4. Well, for 4, it would work because the last 2 digits is 80, and 80 is divisible by 4. But let's take the sum of the digits in 5,680. It must be divisible by 3. 5 plus 6 is 11, plus 8 is 19, plus 0 is still 19. Unfortunately, 19 is not divisible by 3. So we cannot take in exactly $5,680 if we charge $12 per person. So the answer there would be no. All right, take a look at problem number 3. Still dealing with divisibility test. And we want to find out, is 891,133 divisible by 8, 9, 10, and 6? Well, we'll start with the 8. We have to look at the last 3 digits in 891,133, and that's the 133. That must be divisible by 8. And unfortunately, it's not. So here, that answer would be no. Now, what about 9? Is 891,133 divisible by 9? Here the sum of the digits in 891, 133 must be divisible by 9. So if I add 8 plus 9, that's going to be 17, plus 1 is 18, plus 1 is 19, plus 3 is 22, plus 3 is 25. Here 25 is not divisible by 9. So that answer there would be no. Now what about by 10? For this number to be divisible by 10, the last digit must be a 0. In this case, the last digit is 3. So easily, that's not divisible by 10. Now what about by 6? Well, for this number to be divisible by 6, it must be divisible by 2 and by 3. Well, obviously, this number is not divisible by 2 because the last digit does not end with either a 0, 2, 4, 6, or 8. It ends in an odd number, which is 3. So here, that answer would be no. Right, number 4, use the divisibility test to determine whether 1,295,541 is divisible by 15. Well, let me break 15 up into 3 times 5, because I know the divisibility rule for 3 and the divisibility rule for 5. For a number to be divisible by 3, the sum of the digits in 1,295,541 must be divisible by 3. By 5, the last digit must end in 5 or 0. In this case, it ends in a 1. So automatically, this number would not be divisible by 15. So because it's not divisible by 5. So the answer there would be no. Okay. Problem number 5. It says here leap years occur in years that are divisible by 4. However, if the year ends in 2 zeros, it must be divisible by 400 in order to be a leap year. Determine whether the years 1344, 2264, and 900 are leap years. In this case here, was 1344 a leap year? Well, for a number to be divisible by 4, the last 2 digits in 1344 must be divisible by 4. In this case, the last 2 digits are 44, and 44 is divisible by 4, so the answer there would be yes, 1344 was a leap year. Now, will 2264 be a leap year? Well, it doesn't end in 2 zeros, so here we look at the last 2 digits in that number, which is 64. 64 is divisible by 4, so the year 2264 will be a leap year. Now look at this one. Was 900 a leap year? Here, this number ends in 2 zeros. The stipulation says here if it ends in 2 zeros, then it must be divisible by 400 in order for it to be a leap year. Here, 900 is not going to be divisible by 400 because when I divide 400 into 900, it's going to go 2 times with 100 left over. So here, no, 900 was not a leap year. Okay, problem number 6. Here we want to use the divisibility test like I did earlier to determine whether 4,249,233 is divisible by 15. In this case here, well, 15, break that up into 5 times 3. That means that that number must be divisible by 5 and it must be divisible by 3. Unfortunately, 4,249,233 would not be divisible by 5 because the last digit is a 3. For it to be divisible by 5, it must end in a 0 or a 5, and it ends in 3. So, no, 4,249,233 is not divisible by 15. All right, number 7. Does 4 divide 32? That means does 4 go into 32 evenly with a remainder of 0? In this case, it does. So the answer there would be true. All right, number 8 is another set of divisibility tests with the same number, 861,114. We want to determine whether that's divisible by 4, 3, 2, and 6. Well, is 861,114 divisible by 4? We look at the last two digits in this number, which is 14, to determine whether it's divisible by 4. Here, 14 is not divisible by 4. So therefore, 861,114 would not be divisible by 4. Now, what about by 3? Here we take the sum of all the digits in this number to see if it's divisible by 3. Add 8 plus 6, that's 14, plus 1, which is 15, plus 1, that's 16, plus 1, that's 17, plus 4 is 21. In this case, 21 is divisible by 3. So 861,114 is divisible by 3. Now, what about 861,114 being divisible by 2? That will be true because the last digit is a 4. And 4 is divisible by 2, so 861,114 is divisible by 2. Now, what about by 6? Well, for 861,114 to be divisible by 6, it must be divisible by both 2 and 3. Now, if you look at the last two questions that we answered, we found out that 861,114 is divisible by 2 and divisible by 3, so it must be divisible by 6. Finally, number 9, we use the divisibility test to determine whether 3,374,235 is divisible by 15. Well, let's break 15 up into 5 times 3. Because in this case, I know the divisibility rule for 5 and for 3. We can see that 3,374,235 is divisible by 5 because the last digit ends in 5. But what about for 3? Let's take the sum of the digits in this number. 3 plus 3 is 6. 7 will give you 13. Plus 4 is 17, 19, 22, 27. 27 is divisible by 3. So in this case here, this number 3,374,235 would be divisible by 15. Okay, so that should be enough to assist you with some of the problems that are on the MyMathLab homework.